what I have drawn here is the imaginary complex number 4 plus 3i in standard, or you could think of it as rectangular form. Going back to where we did polar form, we had the I vector and the j vector. Well, in the complex world, the real axis is a horizontal axis and the imaginary axis is a vertical axis. So the real number is the horizontal component of the vector and the imaginary number is the vertical component of the vector that represents the complex number 3 plus 4i. Or sorry, 4 plus 3i. So 4 plus 3i would just be this red vector here. So if we're trying to graph a complex number, the horizontal and vertical components show me how to draw the correct vector that represents this vector, or that complex number. Now, if we want to get the trigonometric polar form, it's written like this, r cis theta. And I want you to relate this to something you've already done in the past, which is r at some angle theta. We made polar form, remember that? Okay, back in the, I believe it was maybe 2 chapters ago, maybe last chapter, I can't remember, it was recent that we did this. We did it back in Algebra 2 a lot. We made some magnitude at some angle to represent the polar form of the number. Well, trigonometric form of a complex number is just basically polar expression. The magnitude of the vector, the length of the vector, also known as the absolute value. So the absolute value of 4 plus 3i is equal to r. And r is simply the magnitude, the length of this right here. And the magnitude of this, since this is a right triangle, is this squared plus this squared, take the square root. All right? And when I say this squared, not the I, just the number. So imagining a right triangle, the length of that side is 3, the length of that side is 4. 16 plus 9 is 25, square root of 25 is 5. Okay. This angle right here, which we typically refer to as alpha to begin with, before we establish the quadrant, the reference angle, is inverse tangent the absolute value of the imaginary value over the real value. Again, ignore the I. So if I wanted to get alpha, it's just going to be the inverse tangent of 3/4, which is 36.87 degrees. Using my mental calculator there. The fact that I've done this already once today. So 36.87 degrees is how big that angle is in this right triangle. And since both numbers are positive, it puts me in the first quadrant. In the first quadrant, the angle I'm looking for equals that angle. So theta and alpha are the same in the first quadrant. All right, so to write this vector here in trigonometric form, I'm simply going to write the vector length 5 and then CIS and then 36.87 degrees. That and that mean the same thing. All right? CIS stands for cosine of the angle plus I sine of the angle. That's what it means. So basically, another way of writing this is like this. 5 parentheses, cosine of 36.87 degrees plus I sine of 36.87 degrees. Those mean the same thing. This is just a little more concise to look at. It's prettier. Okay, but they mean the same thing. So with that in mind, that's something we're going to have to do to be able to handle example 2. We'll start with example 2. I'll go back to example 1 after I do example 2. So, write z equals negative 2 minus 2i in trigonometric form. First off, get comfortable with the forms they're talking about. So, when they write it like this, some real number and then some imaginary number, that's called standard form. Negative 2 minus 2i is standard form. Trigonometric form is number CIS angle. That's trigonometric form. That's where we want to go to. All right, so first thing I want to notice here is negative 2 minus 2i, if I'm following my 3-step process for changing into the polar trigonometric form. Step 1, r is going to equal the square root of. And then I'm just going to square both of these numbers. 2 squared is 4. 2 squared is 4. There are no i's or negative signs when you're squaring things. Everything's just the numerical value squared, add them up. So 2 to the second power plus 2 to the second power. That gets me the square root of 8, better known as 2 times the square root of 2. 2 times the square root of 2 is exactly right. 2.83 is approximately right. Anytime you can be exact, it's always better. So 2 squared root of 2 is the best version of that number. 2.83 would be acceptable, but not as good. Step 2. Alpha equals the inverse tangent. It's an absolute value here, so again, ignore all the minus signs. There's no i's in this. It's the imaginary value, numerical value 2, over the real numerical value 2. Absolute value bars make all minus signs irrelevant. Only positive signs matter. Throw out all imaginary things. So just, that makes it the imaginary number. We're just using the number 2. That's the real thing. That's the number 2. So that's inverse tangent of 1, which equals 45 degrees. Okay. If you didn't know that inverse tangent of 1 was 45 degrees, second tan 1 equals 45 degrees. All right, so it's, your calculator can evaluate this stuff for you. It's up to you to know what to type into your calculator. Step 3. We're looking for theta. We found alpha. Okay, so alpha is a reference angle. It tells us how big the acute angle inside the right triangle will be, whatever quadrant it's in. But then we got to measure from 0 counterclockwise around to the actual angle we're looking for. So the quadrant one matters. So if I got negative 2 minus 2i, negative 2 takes me left. Because again, the real axis is left or right. Real number is negative 2, so right is positive, left negative, it's going left. And minus 2y, the imaginary axis is up or down. Down's negative, up is positive, this takes me down. If I'm in any coordinate plane and I go left and down, that's the third quadrant.
180.
And the third quadrant rule is we take 180 degrees plus the angle we just found. That comes out to 225 degrees. And what we're looking for to create the trigonometric form of this complex number, again, is the value of r and the value of theta. And it's always going to be something, CIS something. Okay? This goes here, that goes there. So the correct answer, 2 square root of 2, CIS 225 degrees. Again, it's CIS, not CSI. It's not the TV show, it's CIS, cosine plus I sine. That's how you write it.